It sounds impossible, but the evidence is piling up. Humans may actually be getting dumber. Across the developed world, average IQ scores are falling. Norway alone has seen a drop of 0.33 IQ points every year since the 1970s. Back in the Victorian era, people's brains processed information up to 70 milliseconds faster than ours do now. Meanwhile, genetic studies reveal that the very alleles linked to higher education are slowly disappearing from our DNA. Is this really a consequence of modern comfort, where intelligence no longer determines who thrives, and birth rates now favour those with less education? The disturbing part, no one agrees why this is happening or how much worse it could get. So, what does the science actually say? In the world our ancestors knew, intelligence was a matter of life and death. Outwitting predators, finding food, reading the weather, brains weren't just for show. Those who solved problems survived, and those who survived had children. But something fundamental has changed. In modern societies, almost everyone, regardless of ability, has access to food, shelter, and healthcare. Welfare systems and advanced medicine mean that survival is no longer tightly linked to problem-solving skills. That old, relentless filter, where only the sharpest minds passed on their genes, has faded into the background. Now let's look at who's having children. Across the United States, United Kingdom, and Scandinavia, a clear pattern appears. People with more education, and by extension higher measured cognitive ability, tend to have fewer children. Women with college degrees in the US and UK average about 1.6 to 1.8 children, while those without higher education average 2.2 to 2.5. The difference is even sharper when looking at IQ directly. In large studies, women scoring in the top 10% of intelligence tests have around 1.5 children on average, while those in the bottom 20% have closer to 2.5. Men show a similar, though slightly smaller, trend. Population genetics tells us that if intelligence is at least partly heritable, and studies put that number between 50% and 80%, then these fertility patterns matter. Over generations, traits that lead to fewer children become less common. It's basic math, not a value judgment. The effect isn't dramatic in a single generation, maybe a shift of 1 or 2 IQ points, but it adds up over time. The question is, does this slow, steady change actually show up in our brains or our abilities? That's where empirical testing comes in. Michael Woodley, a British psychologist, wanted to know if modern brains really process information as quickly as those in the past. He turned to a simple but revealing test: reaction time. In the late 1800s, Francis Galton set up an anthropometric lab in London and measured how fast people could press a button in response to a light or sound. The average Victorian clocked in at 183 milliseconds. Today, the same test run on college students and the general public averages about 253 milliseconds, a difference of 70 milliseconds. That's not just a rounding error. Reaction time, or SRT, isn't about how fast you can hit a button after seeing a flash. It's a basic measure of how quickly the brain processes information and sends a signal to the muscles. The faster the reaction, the faster the brain's wiring. Researchers have found that SRT is linked to the G factor, the statistical core of general intelligence. So, a slowdown here isn't just about reflexes. It hints at a broader dip in cognitive processing speed. If Woodley's numbers are right, the implied drop is more than 1 IQ point per decade. But before anyone jumps to conclusions, critics point out that comparing Victorian and modern data is tricky. Old equipment, different testing methods, and even Galton's habit of recording only the fastest of 3 tries could skew the numbers. Still, the gap is there, and it's big enough to raise eyebrows. If true, it means we're not just changing how we live, we might be changing how we think at the most basic level. But is this the whole story, or just one piece of a much larger puzzle? Norway's military records offer a rare glimpse into what's happening on a national scale. Every young man called up for conscription sits the same cognitive test. For decades, the average score climbed. A textbook example of the Flynn Effect. Then, in 1975, the trend flipped. Since then, Norwegian conscripts have lost about 1/3 of an IQ point every year. Over 18 years, that adds up to a drop of nearly 6 points. Denmark and Finland show the same pattern, with declines starting in the late 1990s. These aren't isolated blips. They cover almost every young adult in each country, year after year, using standardized tests and robust controls for family background. Meanwhile, geneticists have been tracking a different kind of shift. Augustin Kong and his team at Decode Genetics in Iceland analysed the DNA of over 100,000 people, looking for genetic markers linked to educational attainment. Their finding? The frequency of these alleles is slipping at a rate that translates to about 0.04 fewer years of schooling per generation. The mechanism is simple. People with more education tend to have fewer children, so the genetic variants associated with higher education get passed down less often. It's a tiny change each generation, but it's measurable, and it stacks up over time. When you put the Scandinavian IQ declines and the Icelandic allele shift side by side, a pattern comes into focus. Both the test scores and the genetics are drifting in the same direction. In societies where advanced medicine and social support have long been the norm. The numbers aren't catastrophic, but they're not trivial either. They raise a question that doesn't go away. Is something fundamental changing inside our heads? Next, we need to ask whether the brain's own biology makes it especially vulnerable to these shifts. Every newborn arrives with a genetic starting line, about 60 to 100 brand new mutations. Most of them are harmless, a few potentially harmful, and a rare handful beneficial. The vast majority slip through unnoticed, but when it comes to the brain, the stakes are higher. Nearly 84% of our genome gets switched on in brain tissue at some point, making it the most genetically complex organ in the body. That means thousands of genes, maybe as many as 5,000, have a hand in building, wiring, and maintaining the machinery of thought. This complexity is a double-edged sword. On one side, it allows for intricate abilities, language, abstract reasoning, empathy, and creativity. On the other, it creates a massive target for errors. Each generation, new mutations scatter across the genome. In the past, most mutations that seriously disrupted brain development or function would have been weeded out by natural selection. Survival and reproduction favored those whose brains ran smoothly enough to meet the challenges of their world. But now, with modern medicine and social support, many mutations that once would have been fatal or disabling no longer prevent people from surviving or having children. Over time, this could let slightly harmful variants accumulate, especially in organs as complex as the brain. The result isn't a sudden collapse, but a slow, almost invisible drift, a gradual increase in what geneticists call mutation load. Some researchers, like Gerald Crabtree, have argued that this process could make the brain especially vulnerable to even tiny changes in genetic quality, simply because there are so many moving parts. No one is suggesting that every new mutation spells disaster. Most are neutral, some even helpful. But with thousands of genes in play and only a light filter on the system, the odds of subtle problems creeping in go up. The brain's complexity in this view doesn't just enable intelligence, it also makes it fragile. Whether this slow genetic drift is enough to dent real-world cognitive ability is still an open question, but the biological logic behind the hypothesis is hard to ignore. For most of the 20th century, IQ scores around the world kept rising. This steady climb, known as the Flynn Effect, added about 3 points per decade to average scores in dozens of countries. The gains were so consistent that some researchers wondered if humans were actually getting smarter, thanks to better nutrition, more years in school, cleaner environments, and fewer childhood diseases. But there is a catch. The same social safety nets, education systems, and medical advances that could mask genetic changes also make it hard to tease out what is really driving the numbers. When the Flynn effect reversed in places like Norway and Denmark, it did not happen in a vacuum. Shifts in education quality, more screen time, changing family structures, and even test design could all play a role. The measured declines, 1 or 2 IQ points per generation, are small enough that they would be hard to notice in daily life. Over centuries, though, they could add up. Still, these changes are slow and technology is moving fast in the opposite direction. Smartphones, search engines, and AI assistants mean that collective intelligence keeps expanding, even if individual scores wiggle up or down. Some scientists argue that the real story is not about a global drop in brain power, but about how much of our problem-solving has moved outside our skulls. There is also a line that cannot be crossed. The history of eugenics, forced sterilizations, racist policies, and the horrors of Nazi Germany shows what happens when science is twisted for social control. Today, any talk of boosting cognitive traits has to steer clear of coercion. Instead, new tools like polygenic embryo screening, gene editing, or brain-computer interfaces are being developed for voluntary use, giving people choices rather than mandates. But these options raise their own ethical questions about fairness, access, and what it means to be human. For now, the evidence points in many directions at once, and the debate is far from settled. Since the Victorian era, measured reaction times have slowed by about 70 milliseconds, and in Norway, average IQ scores have dropped by 0.33 points per year since 1975. Genetic studies like Kong et al. 2017 show a small but consistent decline in alleles linked to educational attainment. While these trends align with predictions from relaxed selection and mutation accumulation, the effect size, typically 1 to 2 IQ points per generation, remains modest. Yet major questions persist. How much of this change is genetic versus environmental? Can technology offset these trends, or are we seeing the limits of adaptation? The historical reduction of brain size, about 10% over 20,000 years, adds further complexity. Today, the evidence does not offer a settled answer, but it demands careful attention. As scientific debate continues, one fact is clear: the trajectory of human cognition is shaped by the choices and pressures of every era, including our own.